When it comes to kinematics, some students really struggle with freefall, and I think that's mostly because if you look at the earlier video with kinematics equations, I gave you an idea of how to solve problems by listing your variables, like what you're looking for, what you have, and what you don't need. And once you have those three things, you can kind of figure out what equation you need. Well, with freefall, you aren't given that information. You're kind of expected to understand what some of the information is just from the context. So I'm going to show you how we can use the context clues to solve freefall problems. Let's go ahead and get started. Okay, when it comes to freefall problems, we still have the same variables that we always have. We have our position variables, initial and final. Again, this is not the final position of the ball. It could, or object. It could just be the position at a certain time. And then we still have velocities, time interval, and acceleration. And remember, your positions could be given as a displacement as well. Okay, let's tackle position first. Up until now, we've probably been dealing with like cars and people going back and forth. Well, for freefall, we're going to be dealing with people throwing stuff up or simply just dropping things. So instead of the horizontal axis here, we're going to be dealing with the vertical. So some students like to substitute y for the axis. Just understand that all your variables are along this y-axis as well. And we can just pick and choose if we want the vertical axis to be positive upwards, or maybe it's easier if we just make downwards positive. That, of course, would make upwards negative. It's whatever works for you. I just try and pick whatever is easiest. If the object is only going downward, that's when I would probably make the downward direction positive. And for freefall, we always treat gravity as acting downward, regardless of where we are in the world. From our frame of reference, gravity is always pulling down. So I know not all of these can be downward, but we're just talking about in local frame of reference. For the velocities here, let's talk initial velocity first. If I have a person with like a tennis ball or something, and they're holding on to the ball, relative to the person, that ball's not moving, and if they're holding it there, relative to the ground, it's not moving either. So if they simply drop the ball, if it wasn't moving, the ball had to start with a velocity of 0, at least vertically. If the person was traveling to the right or to the left, then they could have a initial horizontal, but we'll deal with that later. Okay. Suppose that person were to throw the object up, or maybe the person was going to throw the object down. When the object is thrown, the velocity, the initial velocity, is whatever the person's hands was at, like whatever speed that was at the moment the ball was released. Remember, for freefall, the definition of freefall is that the only force acting on the object is the force of gravity. So we don't use our mathematical models, those kinematics equations, until the hand has let go of the ball. So we're only concerned with the moment the ball has left the hand. And whether that is positive or negative depends on the directions that you chose. For 3, the time interval is the same, nothing really there. But before we move on, I want to talk about the final velocity. Students get confused here. I want you to consider 2 scenarios. The instant the ball touches the ground, it should have a velocity. And the moment when the ball is just laying there on the ground, its velocity would be 0 in that case. Which one do we consider the final velocity of the free fall motion? Well, if you said when it's at rest, that's not going to work, because free fall, again, the only object or the only force acting on it is the gravitational force. And in order for it to come to rest, the ground has to push up on the ball, probably squishing it or something. But either way, we have 2 forces then. We have gravity pulling the ball down and the floor pushing it up, or maybe you caught it in your hand and your hand's pushing it up. That's not free fall if we have another force there. So this is our final velocity. Okay. We'll talk about this piece, or this instant here, when we get to momentum and impulse. All right, let's talk about number 4, acceleration. For free fall, we denote the acceleration with a g, because the acceleration is due to gravity. That's what the g stands for. It stands for the acceleration due to gravity. So it is the acceleration that is caused by the pull of gravity. So the force of gravity is the cause. The g, or the acceleration, is the effect. Be careful with your language here, especially if you're taking AP Physics 1. Try to distinguish between the acceleration caused by gravity and the force of gravity. Galileo's hypothesis it says that everything falls at the same rate. So the question here is, what rate was Galileo talking about? Was he talking about the change in position over the change in time? Or was he talking about the change in velocity over the change in time? It's going to be the acceleration. Because if we look at the number 2 up here, we have 3 different scenarios. All of them are going to experience the same pull of gravity, but they all start out with different speeds. So their speeds are going to change by the same amount. But since they started at different initial velocities, any time interval, they'll have a different velocity compared to each other. So if we threw all these balls at once and we looked at different times, they would all have different velocities, but they would be accelerating at the same rate. So Galileo's hypothesis refers to the acceleration. And for Earth, or near the Earth's surface, that is 9.8 newtons per kilogram. That's how strong, this is the strength of the gravitational field. It just so happens that we can measure the strength of the gravitational field using acceleration, because these newtons per kilogram turns out to be meters per second squared. And remember, it's an acceleration. It does have direction. Whether it's positive or negative depends on what you chose in the beginning. And that's pretty much all I have for the context. One thing I want to talk about before we head out, this last piece here, is terminal velocity. Terminal velocity is the final velocity of an object that's in the presence of air resistance. So it's not really in free fall so much. Let me explain. Consider a falling block. If it has a light mass and a big surface area, the air beneath it, as it's trying to get displaced by that box or block or whatever, that air is going to push up on the block. So not only do we have gravity acting on the object, but we also have the force of the air. This is called drag. Well, when block is just dropped, it's not moving very quickly, so the air isn't going to press up against the block as much. But as it speeds up, the air has less and less time to move around, and eventually the two are equal. When that happens, our acceleration reaches 0. So we go from G to 0. That's why the object stops accelerating. That's why we call it terminal. Consider another instance. Maybe somebody jumping out of a plane. And they're falling, and they deploy their parachute. Well, when they're falling, again, the only thing acting on them is gravity. As they speed up, they're going really, really fast. And when they deploy their parachute, suddenly we have a large force caused by the air. And so what will happen is the person will actually accelerate less and less, or slow down, or sorry, not accelerate less and less, they'll accelerate more until finally the two are equal again, and they reach terminal velocity. So for the block, it might look something like this. We dropped it, and it's going really fast, and but eventually it kind of plateaus. So the parachute, maybe we're already free falling, and then we deploy the parachute. Now the air resistance really matters. We're already going to high speed. That acceleration is going to be really high until we reach a cruising speed. So here we might start out at 9.8 meters per second squared for the air acceleration for the block, and that acceleration is going to slowly approach 0. For a person on that's free falling, maybe they have been accelerating at 9.8 for quite some time. The airbag, or the parachute deploys, and suddenly we get a change in our acceleration, and we get a plateau with the velocity. So that's what we mean by terminal velocity. It's not free fall, because the air resistance is significant. That's all I got for you. Thank you.